Good day, everyone. I will be presenting our group's cache simulation system of a four-way block set associative MRU replacement algorithm cache. My groupmates are Aki Bukuhan, Kyle Gan, Clive Ang, RC Faustino, and me, Adler Strebat. So let's first initialize the values of our cache configuration. Let's assume that our cache blocks is 4 with our line size is 4 as well. Let's initialize the cache. And our select test case for the sequence will be a custom sequence. So let's say 0, 1, 2, 3, 4, 0, 1, 2, 3, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, say 6. Okay. Let's load the data in. So for our cache simulation, we have a next step feature that enables us to see the step-by-step process of the user when the button is clicked. So let's press this so that 0, 1, 2, and 3 will be loaded into the cache under set 0. Since 4, so as you can see in the MRU order, it is basically a list of the data. The rightmost data tells you that the number 3 is the latest data, the data that was brought into the cache. So 4, in this case, since the next data is 4 and we follow the MRU algo, number 3 will be changed. It will be overwritten to 4. Next is 0. So since 0 is already in the cache, we call this a cache hit, as mentioned here, and as well as our log here at the bottom. And this is our new MRU order. Next is 2. 2 is another cache hit. Next is 3. Since 3 is not the cache, it will replace 2 as mentioned in our MRU order from 3. Since 5 is not in the cache, it will replace 3 as mentioned here again. And 6. So since 6 is not in the cache, it's mentioned here that 5 will be replaced. So our final result will be 0, 1, 6, 4. And our total access is 10. Our hit rate is 20%. Our miss rate is 80%. Our average memory access time is 33.8 nanoseconds. And our total memory access time is 368 nanoseconds. I would also like to mention that our program also has a function of a previous step. It basically steps back to the latest step. It brings step back. It's a step back step. So it can bring 6 will become 5 again, then 5 will become 3 again, then 2, 0, 4, and so on and so forth. Then it just goes to next step, previous step. For the second test case, let's say the number of blocks is 8. With our cache line size, let's say it's 4. Let's initialize the cache. And let's say our test case sequence now is sequential. Let's load the input. Our program also has a run all feature that allows us to run the entire process and see the end result when we click run all, without the need to press the next step, next step, next step of this cache simulation. So when I click this, we automatically see the final state of the cache after all the data has been processed. The hit rate is 25%, the miss rate is 75%, the average memory access time is 31.75, and our total memory access time is 1,112 nanoseconds. For our third test case, let's say that the number of cache blocks in the cache is 16 with a line size of 4. And now let's generate a random sequence. Our program has a sequence that has an option that allows it to generate a series of random numbers for the simulation. Additionally, our program also has a function of an auto step function that allows it to automatically show the user step-by-step process of how the data is transferred to the cache, as well as the MRU replacement algorithm in the memory log. So if I click this, as you can see, it will automatically do it for you. And you could also set this, you could also adjust the speed. So you could change it where it's slower, as well as you could also change it so it's really fast. There you go. So based on the random sequence, we can see that the hit rate is 0%, miss rate is 100%, average access time is 42 nanoseconds, and our memory access time is 2,880 nanoseconds. And it's also seen here in our cache memory trace log that there is no hit. It's just all cache miss. Our simulation also works with big data. So we do 1024, let's say 16. Then let's say mid repeat for our sequence. So if we initialize the cache, since the cache block, it is 1024 blocks. Since our cache has 1024 blocks, and it is a four-way set, there should be 256 sets in this simulation. As we can see, if we scroll down, it's 255. And since we are counting at zero, starting at zero, it is 256. So it's loading the cache, and let's do so there's 6,142. Let's try a smaller output so it will not take long for the data to process. So let's say ano na lang, 128. Okay, that gives us 32 sets, right? Then let's load this. Let's start the automation. So can reset this. So if I reset the sequence, it's gonna reset the trace log. So I click this. Let's start the automation. So as we can see, after the automation, we have 512 total access with a hit rate of 25%, a miss rate of 75%, your average memory access time, which is 121.75 nanoseconds, your total memory access time, which is 70,016 nanoseconds, and this is the current state of the cache. Uh, Here's also the memory trace log for the for the for the cache. As you can see that there's some cache hits, there's also some cache miss, right? As well as at the bottom, the final states of the cache, as well as the hits, miss, and the hit rate of the cache. So that ends the presentation for the cache simulation system of a four-way block set associative MRU replacement algorithm. Thank you.